The purpose of this video is to teach you the skill of naming binary molecular compounds. You've already learned how to unambiguously name ionic compounds, compounds in which a nonmetal like fluorine steals electrons from a metal like aluminum. The resulting ions come together in predictable ratios to form neutral compounds. And all we need to do to name the compound is name the cation and name the anion, because there's no other way for aluminum with a 3+ charge to pair up with a fluoride with a -1 charge other than AlF3. But what happens when two nonmetals come together to form a compound? Nonmetals have relatively full valence shells, such as nitrogen and oxygen, and they don't lose electrons very easily. So oxygen can't simply steal the electrons it needs from nitrogen to form a neutral compound. In fact, nitrogen and oxygen can bond in several different ways and form a variety of compounds, such as the ones listed here. If binary molecular compounds, such as these, were named like ionic compounds, this entire set of compounds would be called something like nitrogen oxide. This can't be the case because every new compound needs a unique name. Fortunately, there's a relatively straightforward set of rules to use to name binary molecular compounds. The rules are right here. We simply use a prefix and the element name, followed by a prefix and the element name ending in IDE. With these binary molecular compounds, we don't need to worry about neutralizing charge because these nonmetal atoms are sharing electrons in covalent bonds rather than gaining electrons to form ions. Let's look at the prefixes you'll be using. With only one exception, they should seem pretty familiar. One atom will be represented by mono, 2 is di, 3 is tri, 4, and this is the strange one, is tetra, but it's like a tetrahedron which has 4 faces. 5 is penta, 6 is hexa, 7 hepta, 8 is octa, 9 is nona, and 10 is deca. For prefixes like mono that have the O in parentheses, you simply drop off the O if the element name also begins with a vowel. You might have noticed that there's an asterisk by the prefix before the first element, and there's also an asterisk by mono. If the first element has only one atom, then we do not need to use the prefix mono. Mono is understood. Let's see how these naming rules work with the compounds from the previous page. The compound containing 2 nitrogens and 1 oxygen would be dinitrogen monoxide. You'll notice I chopped off the O from mono and it became monoxide instead of monooxide. Applying the rules to NO2 gives us nitrogen dioxide. Because there's only one of the nitrogen atoms, I do not need to use the prefix mono before nitrogen. NO would be nitrogen monoxide. Again, the mono became mon. 2 nitrogens and 3 oxygens is dinitrogen trioxide. And 2 nitrogens and 4 oxygens becomes dinitrogen tetroxide. Again, we wouldn't say tetraoxide, just chop off the A from tetra and get tetroxide. If you're ever in a bind and can't remember the rules, a really familiar compound that illustrates the rules that you can think of is carbon dioxide. You could also think of carbon monoxide. You would never say monocarbon dioxide, and you would never just call this carbon oxide. So these two compounds can help you think of the rules to not use a mon before the first one and to always use a prefix before the second element. Pause the video and use the prefixes at the top of the page to practice using the naming rules for binary molecular compounds. Unpause the video to check your work. The first compound is named phosphorus trifluoride, 1 phosphorus, 3 fluorides, carbon tetrabromide. You'll notice this time we needed the A in tetra because bromide begins with a consonant. Once again, we've not used the mon prefix before one element in either phosphorus or carbon. And finally, we have tetraphosphorus decoxide. In conclusion, memorize the prefixes above, and if you need to, think about carbon dioxide to help you remember the rules for naming binary molecular compounds.